Seguimos siendo pioneros. Y apenas hemos empezado. Nuestros mayores logros están por llegar. Nuestro destino está escrito en las estrellas.
The initial impetus for the project had been to say, why not examine real possibilities? Why not actually look at the real science there?
Luckily, we had Kip, and Kip is the foremost authority on all things gravitational.
The warping of space inside here scatters some of it back, light scattering off of the surface of a rippled ocean.
Neither wormholes nor black holes have been depicted in any Hollywood movie in the way that they actually would appear. This is the first time that the depiction began with Einstein's general relativity equations.
The visual effects department under Paul Franklin and everybody at Double Negative took Kip's mathematical data and they created real visual representations of what a black hole is meant to look like.
The collaboration has produced visualization of things which nobody had ever managed to do before. We potentially may have discovered a couple of new things that were lurking there inside the mathematics, inside the physics.
I worked out the equations that would enable him to do the gravitational lensing. And so you have light that comes from a star behind a black hole. It may come in, go around the black hole several times, and then come to the camera. And so you wind up with several different images of the star.
The black hole warps the space so much, it just looks like you're looking at a strange sort of funnel in the sky with this intensely black circle at the middle of it. But the gravity of the black hole draws in all the matter from the surrounding universe. And this spins out into a giant disk around the central sphere. And as it whirls in towards the center, the gas gets hotter and hotter. And this thing, the accretion disk around it, shines brilliantly. And then we found that if you then render this whole thing, you visualize it all through this extraordinary gravitational lens, the gravity twists this glowing disk of gas into weird shapes, and you get this extraordinary sort of rainbow of fire across the top of the black hole.
And I saw this disk wrap up over the black hole and under the black hole. I'd known it intellectually, but knowing it intellectually is completely different than seeing it, than feeling it.
We had determined when we started down this road that if it didn't look like something that would be comprehensible to the audience, we would have to manipulate it in some way. But what we found was, as long as we didn't change the point of view too much of the camera position, we could get some very understandable, tactile imagery from those equations. They were constantly surprising. Spoke to the maxim that, truth can be stranger than fiction.
We're going to write several technical papers about this. One aimed at the astrophysics community, and then something for the computer graphics community, saying, here are some things that we've discovered about gravitational lensing by rapidly spinning black holes that we never knew before. So this collaboration isn't over until we've given some sense of the things that we've learned.